Section 10.3 has to do with properties of a logarithm. Another way of putting this is the math that you can do on the logarithm. The product property of logarithms are what you do when you have two things that are multiplied, like m and m. You can write them as two separate logarithms, the log of base b, which would be the same as this, of m plus the log of base b of n. So in other words, when you have two things that are multiplied with logarithms, you do an addition. So here's an example of this. They often will give you at the top a value that you're going to use in the problems that follow it. So you're going to turn around and you're going to write this logarithm. You're going to figure out how to write it with a number of 5 and a base of 3. So I would do something like this. The log of base 3 of 5 plus, because 5 times 9 is 45. So basically I'm talking about this. Okay, but then I can turn around and go, 9 is the same thing as 3 to the second power. So I could say the log of base 3 of 5 times 3 to the second power. So now I'm going to separate it into an addition problem. The log of base 3 of 5 plus a log of base 3 of 3 to the second power. Now, the log of base 3 of 5, I can get that value right there. So I have 1.4650. This value, if you remember from the other section, the log of base 3 of 3 raised to the second power is going to be that value right there. So my final answer here is 3.4650. That is the log of base 3 of 45. All right, if I did this one, I could write this as the log of base 3 of 5 squared, or another way of putting that is the log of base 3 of 5 times 5. So then I'm going to take that multiplication and I'm going to change it in terms of an addition. So I have a log of base 3 of 5 plus a log of base 3 of 5. Each one of those is worth or equal to 1.4650. So 1.4650. When I add those together, I am going to get a 2.93 as my answer. So here's another example done out here. So the biggest thing is going, how can I write this? So this time they give me both the log of base 12 of 8 and the log of base 12 of 10. I can write this then as the log of base 12 of 8 times 10. So separated, I have the log of base 12 of 8 plus the log of base 12 of 10. So this value I get from right there, it's going to be 0.8368. This one is going to be right here, so 0.9226. So I'm just going to have to add those two values together, 0.8368 plus 0.9226. And I'm going to get a value of 1.7594. All right, now this one looks like it could be a little bit different. You've got 96, which if you think about how you can multiply things together to equal that, that's the same thing as 8 times 12. So I have the log of base 12 of 8 plus the log of base 12 of 12. So you're trying to find things that you can get a value for. So the log of base 12 of 8 I get from right there. So it's 0.8368. The log of base 12 of 12, remember, is going to be that exponent right there. So my final answer is 1.8368. The quotient property of logarithms is somewhat similar to it, but rather than adding, you are subtracting. So if you have division, which is a quotient, you're going to subtract this, the log of this, minus the log of that. And here's some examples done on this. They give you the log of base 4 of 5 and the log of base 4 of 15. So you're looking here and you go, well, that can be written as the log of base 4 of 5 over 4 squared. So when I write it out as subtraction, I have the log of base 4 of 5, which I know the value of, minus the log of base 4 of 4 squared. So this value is 1.1610. This value, remember, is going to be that. So I have 1.1610 minus 2, which is going to be a negative 0.839. This one over here, you look and you go, oh, well, I don't have anything. That is 3. But you can write this as a log of base 4 of 15 divided by 5, because that's the same thing as 3. So when I write it as a subtraction problem, I have a log of base 4 of 15 minus a log of base 4 of 5. The 15 is 1.9534. Got it from right there. Minus 1.1610. So let me do that out. And it's going to give me 0.7924. Let's do another one. We've got 5 divided by 64. And you have a log, I think this was supposed to be a 5 right here. I'm missing that. And then I have a log of base 16 of 20. So I look at this one and I could write it as a log of base 16 of 5. And then that's 16, I'm looking here. That could be 8 squared. Let me make sure it was supposed to be a 5. No, it was supposed to be a 3. It's a log of base 16 of 3. And then that one was a log of base 16 of 20. So you have got a value there. Let's see, I could make this, hold on one second. If I multiply the top of this by 4, and let's multiply the bottom of that by 4, because I'm trying to be able to use those two values. So okay, so when I do that, I'm going to get a 20 on the top, and I'm going to get a 256 on the bottom. Okay, 256 is the same thing as 16 squared. So I have a log of base 16 of 20 divided by 16 squared. So when I do it subtraction, I have the log of base 16 of 20 minus the log of base 16 of 16 squared. The the log of base 16 of 20 is 1.0805, and then the log of base 16 of 16 is 2. So 1.0805 minus 2 is going to give me a negative 0.9195. All right, this one over here. This one's a little bit easier. I'm just going to take the top, the log of base 16 of 3, minus the log of base 16 of 16. So I'm going to have 0.3962 minus 1.3962 minus 1 is going to give me a negative 0.6038. Okay. All right, then you have the power property of logarithms. The power property says if you have something raised to a power, that can be turned around and brought to the front of the logarithm. So you see how they took the p off of the power and turned around and multiplied it in the front. So now we're going to take everything that we've talked about so far and put it together. If you will, on this particular problem, I can take these things that are in the front and put them back there as powers. Okay, so I can take the log of base 3 of 6 raised to the second power minus the log of base 3 of 16 raised to the 1/4 power is equal to the log of base 3 of x. Now, this is the same thing as the log of base 3, 6 squared will be 36, minus the log of base 3, the 4th root of 16. If you remember right, the fraction and the exponent means that that's a 4th root. If that had been 1/2, it would have been a square root. But the 4th root of 16 is 2. So remember, this is division, so I can rewrite this as the log of base 3 of 36 divided by 2 is equal to the log of base 3 of x. The logs cancel out, so I've got 18 equals x. And you would have to plug it back in for the x to make sure it doesn't make anything undefined. And you can do, you literally can have 3 to some power is going to equal 18. So you would go backwards here and take this and put it in exponent form, and there is something you can put right there that will raise 3 to the 18th power. All right, let's do this one. Now, notice I have an x there on the 4, on front of it, so I've got a x raised to the 4th power when I rewrite this. So I've got x to the 4th power, and I want to somehow write this with exponent form. So I know that that's the same thing as 3 to the 4th power will give me 81. So you notice the exponents match, so the base numbers must match, so x is equal to 3. And that would work when you plug it back in. All right, let's look at this one. This one, you have addition, which means I'm doing multiplication on this. So I have a log of, and let's do multiplication. This is going to be difference of squares, so it's going to be y squared minus 144 is equal to 2. Now, if I have a log on one side, I'm going to need to turn around and write this in exponential form. So I'm going to take the 5, the base here becomes my base. That becomes my exponent, and then I have y squared minus 144. So I have 10 here is equal to y squared minus 144. So I'm going to add the 144 to the other side, if you will. So I have 154 is equal to y squared. Well, so I can take the square root of 154, and it's going to be plus or minus 12.4. Now, understand though, if I put the negative in here, it isn't going to work, because then I'm saying 5 to a certain power is going to give me a negative 12.4. There is no power up here that you can make this positive turn into a negative, because if you put a negative power, all it means is you would take it and put it to the bottom. So there literally is no way to take a positive number, raise it to a power, and get a negative number. And that's what you would have to do right here if you plugged your negative 12.4 in there. So that means that my only answer is positive 12.4. All right, let's do a couple more. This one is multiplication, so I am going to multiply. It's addition, so I know it's going to be multiplication. So I'm going to take z times z plus 3 equals 1. So I have the log of base 10. When I multiply that, it's going to give me z squared plus 3z equals 1. Again, I have a log on one side, so I'm going to write it in exponential form. So I have 10 to the first power is equal to z squared plus 3z. So this raised to that power equals that. I want to take everything to one side, so I have z squared plus 3z minus 10 equals 0. I know I can factor this, so I get z and z, 5 and 2. The 5 needs to be positive, the 2 needs to be negative. I set them both equal to 0, and I get z is equal to negative 5, and z is equal to positive 2. If I plug negative 5 back in here, I am saying 10 to some power is equal to negative 5. Now remember, I can't take a positive number, raise it by an exponent, and make it be negative. So I know that does not work. So the only answer here is that. All right, this one is a division problem because you have subtraction. So I have the log of base 10, and I can say x plus 3 divided by 2x minus 1 is equal to the log of base 10 of 2, because I have a single term on both sides, no addition or subtraction of logarithms. I can look at the log of base 10 and it cancels out on both sides. So I am left with 2 equals x plus 10 over 2x minus 2. I'm going to multiply the 2x minus 2 the other side, so I have an x plus 3, and I'm going to distribute, which is going to give me 4x minus 2. And then I've got to solve for my x. So I'm going to subtract the x. I'm going to get a 3x. I'm going to add the 2. So that's going to give me a 5, and I'm going to divide, and that gives me x is equal to 5/3. And that does not make it undefined when you plug it back in. So that is your singular answer. All right, your homework is on page 615. 18 through 44 even. Okay, just do the best job you can, see what you can accomplish out of it.